Evening, everyone. So tonight I'm talking about a new concept that was introduced recently in Xamarin.Forms called native view declaration. So the title is slightly different to what it was advertised at. That's because I got the marketing terminology completely wrong. I'll go into it a bit later. Basically, it allows you to nest a native iOS or Android or Windows view directly in XAML, which is pretty cool. For those of you who don't know who I am, I'm Matt. I've been working in the Xamarin ecosystem since 2013. I currently work for JobAdder, and in my spare time I build a productivity tool called Mfractor. So that's me. So firstly, what the heck is native view declaration, and what does that actually mean? The best way to sum it up is just with this one GIF. So Pierce Bogan, who is one of the technical product managers at Microsoft, did this product demo which demonstrates what native view declaration can do. In summary, it allows you to take a view that you'd normally have to wrap in a custom renderer and reference it like you would any other control in Xamarin.Forms. So in this case, he has made a new XML namespace called iOS color picker, and up the top here he would have referenced the iOS assembly, which contains that color picker, and you can just drag it in like you would any other control, and it will do all the bindings for you. It will do everything automatically. You don't have to touch renderers ever again, or so you think. I'll get into that a little later. So it's quite cool because it lets us just take any native control and just drop it straight into our XAML without a renderer. So no renderer, that's awesome. And it's awesome for prototyping because all of a sudden this whole control library opens up to you that you've never been able to touch because the cost of dropping it into your app is too high. And it's almost too easy to do just based on that previous GIF. So to add a native control, firstly you need to upgrade Xamarin.Forms to 2.3.3-pre2. And that's important because that's where the support was introduced. And that's pre-release, by the way, so I wouldn't recommend using that in production just yet, but have a play with it. Just create a new XML namespace. So for instance, for iOS, you do something like XML.ns iOS or XML.ns Android. And with that namespace, you would target the assembly and .NET namespace of the control you want to import. You add a target platform directive, which is really just a fancy enumeration that when your XAML is inflated at runtime, they exclude anything that doesn't match the platform that you're on. And then you just stick the control in. So your XML namespace and the control that you're trying to reference. So this is a demo. This is some source code that I'll show a little later. But it does demonstrate how it works. So first of all, we've got our namespaces. So our Android signature pad namespace and our iOS one. And these don't really matter at runtime. They'll just get inflated out, but they're ignored. These reference the .NET namespace that the control lives in. The .NET assembly that the control lives in. So when your final app bundle goes out, it's looking at the assembly cache within your app bundle for something called signature pad. You specify the platform, so Android or iOS, and then you just drop the control in. This X arguments thing is important for Android, and I'll get into that in a minute. So often we need to when we're using a custom control, a lot of them will come without a default constructor. So Xamarin.Forms by itself, they always have a parameterless constructor so that they can inflate their elements. Which is a problem because most Android views, probably all, they will require a reference to an Android context. So the activity, the fragment's not context, I don't think.
It has its own.
Yeah. The enclosing view group or whatever it is. Yeah. So we accomplish that using X arguments, which is a directive in XAML, which specifies parameters to provide to a constructor. So based on that previous example, the signature pad view does not have a default constructor. We cannot create it if we don't use the context constructor. So in this case, we need to use an X-static expression to grab out the global Xamarin.Forms context and drop it in to the view constructor. And prior to that, we would have built a, oh shit, pick that one up. We defined a XML namespace that references into the Xamarin.Forms assembly, so we can grab that global forms context reference. Things can get quite verbose though when you're using the X arguments directives. So just that previous demo that I was pointing out, he's pulling in a color view, which does not have a default constructor, but it does have a single constructor to take a CG-rect. CG-rect has multiple constructors, so then you need to provide more X arguments into the CG-rect constructor. So you end up with this just a lot of XAML code just to import one external view. So, out of the box, we get property binding, which is pretty cool. So any native property that is on a native control, they'll get a proxy around it, and you can just attach a binding, static expressions, whatever you want. Two-way bindings work out of the box. To do this, we just simply use a markup extension like what we used to. So if I wanted to change the line color on our signature pad view, I just use a binding expression to do that. And it's really just that straightforward, which is super cool because there's no work that goes in. There's not really any more work that goes into this. Now we just use it. So how do they actually do that? When your view is inflated at runtime, they wrap it in a Xamarin.Forms proxy object. That will implement iNotify property changed, and it will generate some bindable properties that are used in replacement of the native properties. And then it just simply forwards them onto the native view. So since we can do property binding, it raises the question of if we're binding to native properties, we're going to be binding against native objects, and they won't come back into our Xamarin.Forms assembly. So our PCL just won't be able to process them. They're unknown types, we can't use them. So you'll get all kinds of inflation errors and stuff at runtime. The way around this is we now need to start writing custom value converters that would take, for instance, a UI color in iOS and convert that into a Xamarin.Forms color, or an Android graphics color going to a Xamarin.Forms color, and vice versa. So there's a lot of value converters that are going to have to spring out to really support this properly. So we would create a new color converter for both platforms, put them into the resource dictionary for that page, and then we can just drop them straight in as a static resource converter. And so that would take the UI color, the type for signature color, drop it into the color converter, and then it will output out a Xamarin.Forms color. So this would be the implementation for Android. So we're taking in the Android graphics color, sending out a Xamarin.Forms color, and vice versa in the convert back method. It's much the same when we're using, well, it's much the same for iOS as well. Demo time. So I've been working on a small demo to run through how this works. Is it big enough?
Probably not.
Okay.
Bigger.
One more. Yeah.
Okay, so this is the starting point for my demo. As you can see, we've already got a heap of new XML namespace statements just so that we can get custom controls in. So in this, we've got a iOS and an Android signature pad. So referencing the external signature pad assemblies. So this signature pad is a Xamarin component that I've included into the native Big Declaration demo Android and iOS projects. And within that, we've got, this is just some happy code that just, this is the control that I'll be pulling in a bit later. So I'll close that down. And then a bit further down, I've already got a iOS signature pad and an Android signature pad nested in. And in order to create the Android signature pad, I need to use that ecstatic expression to provide the main constructor. Some other important things to note is I am referencing Xamarin.Forms 2.3.3 pre2 in all my projects. So that's in the Xamarin.Forms project, the Android and the iOS project as well. All right, and so just to quickly prove that that works, if we start up our iOS demo, so that's the native signature pad view dropped directly into our XAML with zero custom rendering code. So that's probably saved us 100 lines per platform.
Hours.
Yeah, like it's
No prototyping, it's just straight.
yeah. So if you have a charting library that you want to test, and like just to get a client and go, hey, like this is what it could look like, you can just make that work in an instant for them. So it's amazing for really fast turnarounds. Anyway, I'll jump back and keep going. So if we wanted to access a property and apply it into one of these controls, and I'm just going to work in iOS in this demo, just to save some swapping around. We can just directly access that property like we would for any other control. Now, I'm not sure if it's just my IDE or if it's a global bug thing, but the property IntelliSense doesn't seem to quite work for native controls yet, which, that's fine, we can get around it. So I know there's a property called signature prompts, prompt text. Which that will control, I think it's just here. So we can set that as we want. So first of all, we could just go like sign here, please. If I just redeploy that, you can see that it will directly set the property for us. So that's just a literal inline value for starters. So that's bound the Xamarin property and setting through to the native control for us. What we can also do, we can change that into a binding expression. So if I do a new binding expression and say I want to do just a new field called message, a new property called message, sorry. And I can then go notify changed, and I can set that backing field to sign here please, or I might change it. So when that starts up, so that is now coming from our binding context. We can take that a step further and we can do two-way data binding. So if I added a entry field, just above it, and I bound text also to the message, what we'll get, screw that up. So what we get now is two-way data binding. So we can control the message property through our entry label, and it will automatically forward it through into our native control. So I can just, as I delete that, it'll update it straight away. Yeah, so I think that's pretty cool that we can bind it. Yeah, do two-way data binding. We can also use, so that particular field, string is available, system.string is available in both the signature pad library and our PCL that we're using. But what if we wanted to change, say, a UI color type property? In that case, we'll need to start using value converters. So let's change. Let's first of all, we'll add we'll control the stroke color. So So it's going to try to pull out the type information for of the actual type first. So we'll just change that to a Xamarin.Forms color.
Was that your plugin doing that, or?
Yeah.
Yeah.
Just quietly. Yeah. Okay. Yeah. So all this code generation that's happening is my plugin.
What's it called?
I'm terrible at this. Mfractor. So if you do want to save yourself a shitload of work, use my plugin and it will do a ton of code generation for you. All right. So we'll change that to, say, Aqua. Now, by default, that's going to evaluate. It's not going to evaluate properly, so it's returning a Xamarin.Forms color into a UI color field. By the way, this analysis is also Mfractor, so just keep going. So we need to take that UI color and convert it into a Xamarin.Forms color, and both ways. I've already written and imported some color converters to do this. So
What happens if you run it without the converter?
it'll just explode on inflation. I can do it. So if you don't use the color converter, it will not start. Like that screen will firebomb the minute you try to use it. Boom.
So it's just a cast error.
Yeah.
Yeah.
But I mean, if you're using a character, it'll tell you that anyway.
You got the hang of this.
I've got the hang of it. Yeah. So use my tool and save yourself this pain.
Yeah, it's good maintenance.
Yeah. So we need to make sure that type gets converted properly, because otherwise our pages just won't load, and that's a pretty shit out. So I'm going to drop in the color converter. Resource, iOS color converter. So what that's going to do now, the value converter is going to intercept that, and it's going to take our UI color and convert it to a Xamarin.Forms color, and vice versa. So now if I run it, it will not only not firebomb, which is great because we like our apps to actually work. The stroke color will have changed from black to blue, and that will be driven through our binding. So, hey, it's pretty cool.
Good.
All right, enough of that. So yeah, it's a pretty handy tool, and once it matures, it's going to be, it's just going to wipe out custom renderers basically. Well, kind of. It's kind of going to wipe out custom renderers. So it's got a couple of limitations, just a few. You can't use it with compiled XAML, which is a bit sucky because you then have a 5 times performance penalty, because compiled XAML is way quicker to construct than inflated XAML. You can't use XName, because XName will try to bake in the actual type into your PCL when it generates the field, which eliminates, say you wanted to you want to XName your color pickup and then drag that color out into another control without any kind of gluing code back into the binding context. You just can't do that. It won't compile.
That means
Does it mean
code
that you cannot use that control in the code behind in your source
No,
code?
you can't use the code behind.
Really?
No, not yet. I'm sure they'll do a solution for it. I've got it in PCL because I've only tried it in PCL. I've got a feeling that in shared projects they might put like if defs around it, maybe. Someone,
If you wrap it in a component and you turn off compilation for that specific area,
yeah.
does it work? Or like if you've got like a container page and that's got the XAML C on it, and then like one of the other controls, you'd like
Honestly, I haven't
skip
tried
it? Okay.
Yeah.
I wonder if it would. I might.
Don't know. We should have a play and figure it out. It's got a lot of little quirks, and I've got a feeling that it's got a few bugs as well. I kept running into issues when I was writing these demos. The shady side of this, and there's a bit of an underbelly, it really explodes out your XAML code. So if you want to just drop in a control, and that control needs to convert, well, first of all, if it's got a custom constructor, all of a sudden you need to do some XML NS using directives just so that you can use some potentially other constructs to provide to that constructor. And then you want to bind to it, then you need to do some more XML NS just so you can get those value converters in. Then you need to add them to your page's resource dictionary. Then you need to actually make that custom constructor. It just gets out of hand really fast. So because of that, in my personal opinion, it adds some tech debt. So all of a sudden, instead of just one flat control, so if you've just written a custom renderer for like a circle view rather than pulling in a platform-specific one 3 times, you've just made like 3 new views in your XAML that are just going to be harder to maintain. And XAML's harder to maintain because it's not C#. Like you don't have all the nice refactoring and stuff on it. It's just more hard to work with at the moment. And you no longer have a flat API surface like you would with a custom renderer. So if you just had written your own circle view control with custom renderers for each platform, you can just drop that in once and it will do all the hard work for you. But now you've got like 3 different implementations, with like 3 different properties on each one that you're binding to. It just gets out of hand.
Commanding or eventing, or is it available?
Events?
Yeah, like event or command.
I haven't looked into that yet. I didn't get deep enough. I would say in that case you're probably looking at doing potentially a value converter to take the event into a command if it's not supported out of the box. Yeah. So for me, my takeaways from this is that you should use it for rapid prototyping. If you just want to get something out to the client as a proof of concept, this is awesome for dropping a component in to demonstrate, hey, we can do this, and we can do it faster than the competition. And it's great, like if you know your view is just going to use one feature just for that one platform, so that charting control is only going to happen on iOS, then by all means use it. But once you start having to place it in for Android and Windows as well, you end up with those like 3 different view code paths, and it just gets messy. And if your XAML's inflated, then yeah, you can use it. I would reconsider using it if you need to consider maintainability in your XAML code in the future. You just have to look at just look at that. It's just gotten out of hand really easily. Like that could have just been one control with a custom renderer and all the other source codes in C# that manages that platform delegation. But now we've got our control, then the X arguments to provide the CG rect, the import statement for the CG rect, the CG rect's own X arguments for the constructor. It's just a lot of code to bring in just one view that we want to use.
Matthew, there's nothing technically stopping you from taking that code though and putting it in its own XAML file.
No.
So potentially you could end up with a kind of XAML skeleton and then the XAML specifics that you just import.
Yeah.
So that would be one way potentially of managing the...
Of mitigating the problem.
You treat it like a resource dictionary, like with colours and themes and fonts.
Yeah.
Yeah.
Or you could like inherit from it in your native control, and if you want to do native stuff, you don't actually have to create a custom renderer. You've inherited from this, and then you're referencing the inherited one.
Yeah.
And then do whatever you want.
It's ready to solve the problems for me. Cool.
So is a UI view in the toolbar.
Sorry?
All we need now is a UI view in the toolbar.
Yeah.
So at the moment, what sort of percentage of libraries does it cover now?
Native view declaration.
Yeah, I mean the iOS and Android, all the libraries.
Yeah, everything. Like
Everything.
You can pull in anything you want.
Really?
Yeah, it's all out of the box supported.
Wow.
Freaking nuts. And the only thing that's support is the value converters. Like over time, they'll ship more value converters, but you've got to write them.
There's going to be, at the moment, it's tedious. You have to write value converters for everything. But once people latch onto it, expect an explosion of like a value converter ecosystem, I guess. Yeah. And yeah, which is interesting because when you have like a UI color to Xamarin.Forms color value converter, you also need one the other way around in case it maps the other way as well. So yeah, there's going to be just heaps and heaps of stuff that comes out to make this work properly. Yeah. So in my opinion, for native view declaration and custom renderers, like they're both great. It's just different tools for different problems. So I will use native view declaration for prototyping. I probably wouldn't use it in production just yet. And if I want just a flat control, I'll use the custom renderer because I personally don't find that hard to write once you have a familiarity with the APIs. Yeah. I'll release the slides of this later and maybe the source code and stuff as well, I guess. But here's some resources that I've used for this. So the first one is the release notes, which kind of does a really quick proof of concept in how to drop this stuff in. The second one is more of a thorough product demo. So Keith Bogan goes through and kind of goes, this is how you do it, this is how you import assemblies and blah, 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 blah. And the final one, if you're interested in the technical implementation of it, Stefan was the original one who wrote this. So you can jump into his GitHub commit and kind of dissect what he did. And it's quite interesting, like how he's built this wrapper around native controls and forwarding through the properties and stuff. It's fun to have a look at. Yeah. Anyway, if you want me to talk about something in the future, there's some ideas as well.